Welcome everyone to the lecture series of Marketing Research and Analysis 2. In the last class, we had discussed about research question and hypothesis development. So, we just learned that research question is basically an exploratory comes from an exploratory study. So, where the researcher puts in a question when he does not have any knowledge, and hypothesis somewhere where you have some knowledge about the the subject of study, and then you try to develop some propositions, you assume something so that you can later on try to prove it, test it and prove it. Okay. So, but before that the very important question that comes to mind is what is this, how to develop this hypothesis. So, let us look at the slides. This was from the last class. If you can see, this is how the the hypothesis looks like. So, you formulate the hypothesis at the beginning. So, the H0 stands for null hypothesis, H1 stands for the alternate hypothesis. Then once you test develop the hypothesis, which I said how this is very important, because if you go wrong in it, then maybe you are testing the wrong hypothesis. So, maybe I will show you again a little bit. Then after that we select the right test. So, what are the right tests? So, there are various tests to test your hypothesis. So, which test is the most appropriate test in your case, that needs to be learnt. Then comes the level of significance. Now, what is this level of significance? I will explain, right, and it is very important during a hypothesis test. Finally, we calculate the statistic and then compare it with some table value, or and then say whether the hypothesis is to be rejected or accepted, right, rejected or not rejected rather, you can say, right, and finally draw a conclusion out of it. So, let us this is what we had started with. So, null hypothesis is, as I had said, is something that is a statement of the status quo, means something that is going on and you want to maintain that. So, if I remember, if you go back to Newton's law of inertia, where it says ki every body continues to be in a state of rest or continues moving until unless something external force is applied over it. Similarly, the null hypothesis is the same thing. It says it does not change until unless something happens, right. So, the question is the null, when you make the null hypothesis. So, if you in this case if you see, so we are saying there are two things, one is the mu, which is the population mean, right, and mu 0 is a hypothesized parameter value. Now, this hypothesized parameter value, for example, when I will explain you about one sample test or something, then you are comparing the sample mean with the population, a hypothesized population mean, and you try to see whether actually there is a difference, significant difference exists or it does not exist. On the other hand, the alternative hypothesis is something where we are trying to see that a statement that some difference is expected. That means, as I said in the last class also, the alternate hypothesis is the one which the researcher is more interested in almost generally in almost all the cases. There are few cases where the researcher is also interested to test the null, wants the to accept the null hypothesis, but there are very limited cases. Generally, when we talk about in a marketing or market condition, we will always think of the accepting the alternate, right, and try to disprove the null hypothesis. That is the most important thing that a researcher thinks of. Okay. Similarly, as I said, so in this alternate hypothesis, what is happening, if you can see, mu is not equal to mu 0, right. So, the population mean is not equal to that hypothesized value, right. Mu that means mu can be less than mu 0 or mu can be greater than mu 0. So, this is the case that we are talking about, and as I said, the null hypothesis is the one that is always tested. So, if you will see here, I had put in a a humorous picture ki the person is thinking where to move. So, what happens if I make a mistake in writing the null and the alternate. So, if you make a mistake, that means suppose you write the H0 as the one which you were writing for the alternate, right, suppose you make this mistake, then what is happening is you are actually testing this one, right, you are testing this hypothesis. So, ultimately the inference that you will draw, you will be according to this one, right. So, that means you have already made a big mistake. So, what you should have been rejecting, maybe should you have accepted, or vice versa it has happened. So, you have need to be very careful. So, to do that also I had said one thing, since most of the time since the null hypothesis is an equal to case, no change, right, there is equal to. So, A is equal to B condition. There can be another statistical condition which can be greater than or less than. Okay. So, the easiest way, the easier way to write a hypothesis or develop a hypothesis, try to see what exactly do you want to check, right, and the one you want to check accordingly, or you want to disprove, right, because the intention is to disprove the null hypothesis. So, what is the researcher actually wanting? He wants to know, suppose the advertisement, he makes an advertisement, let us say a company is making an advertisement and he wants to test the effect of advertisement on sales. So, the null hypothesis says advertisement has got no effect, correct, because at this moment we cannot say anything. So, what is the researcher wanting? The researcher actually wants in his to see the null hypothesis should be wrong, that means advertisement should make some effect, right. So, that should make some effect could be sometimes it is a bad advertisement, it will have a negative effect, it is a positive advertisement or a well accepted advertisement, it will have a negative positive effect, right. So, in that case you are going for the not equal to case, right, that means the change in sales, is different, that means the initial sales that you had prior is different to the, let us say, the later one, let us say, okay. So, this condition is what we are basically checking. So, whenever you are making an hypothesis, kindly be very clear what exactly are you thinking or do you want from this test, right. The one that you want, please write it in the alternate hypothesis simply, right, and the equal to case along with, maybe it is an equal to, or let us say equal to and greater than, let us say, right, or equal to and less than, right, condition, then that is one you take it to the other one, the null hypothesis. So, forming the null and alternate is actually some you need to be very clear about it. So, let us today talk about this thing. So, initially when I said you develop your null and the alternate, the null sometimes it is also taken as like this, some places it is written it is written as HA and HB, right, H1, H2, the null and alternate. So, this way it is written, right. So, the question is, after you have the null, then what you do is you need to understand the direction of the test. Now, what is this direction and why it is important? Direction of the test means what is the side the test is moving, that means suppose you want to see whether the sales is increasing or not, only I want to see whether sales is, I am not concerned whether sales is falling or not, let us say. Then in such condition my interest in the let us say in the normal distribution, I am not interested in the negative side, I am not interested. So, I am crossing this. Where am I interested? I am moving, it is whether it is increasing or not. So, I am looking at only this side, right. In some condition it could be different, it could be like I am interested whether the price will fall or not, the sales of cars will fall or not, increasing, suppose I am not interested, the company is not interested in this part. So, he is only interested in this part, could be. In some conditions you do not know anything, so you are clueless. So, that condition you may go either this side, this is also true, this is also true. So, this is another kind of where it is a two tailed, right, and we even it is a non directional inside in the last class we had discussed. So, these two are directionals, this is a non directional. So, as you can see, what is this direction of the test? Let us go. The location of the rejection region. So, the rejection region, now let me clear it for your benefit, again I will show you. So, the location, this is the, let us say, the normal distribution, right. So, the as you know, the mean, median and the mode all lie on the same axis, okay, in the normal distribution. So, the question here is what is saying, the location of the rejection region. Now, what is the rejection region? Now, there is a term that you need to be very clear. Two terms are very important, one called the confidence level and second called the confidence interval, okay. So, what are these two things? So, to understand properly, confidence level is nothing but the probability that a confidence interval will include the population parameter. Now, what does it mean? And what is this confidence interval? It is the range, it is the range. So, the let us say the range is up to this much. So, I am saying that my class interval, that means the range into which the true population parameter will fall. Now, what are the true population parameters? Population parameters are like, for example, the mean, right, the standard deviation, right, the variance, okay. You can have the proportion, right. So, these are all the parameters that you need to check or you are trying to check, right. So, it says the population parameter falls, basically the mean, we are talking about the mean in this case, falls within a standard region. So, if it is falling within this region, right, then I am saying ki, well, my this is my desired limit, okay. Now, the question is at what probability, at what is the probability at this, at which this confidence interval is lying, that is that changes, okay. So, I may have a 95% confidence level, right, I may have a 99% confidence level, I can have 90% confidence level, I can have various confidence levels, okay. So, at what confidence level are you talking about it? So, when you are talking about the different confidence levels, automatically the mean will start shifting, okay. So, what it is saying, the location of the rejection region. So, if this is my acceptance region, this is my acceptance region, what is my rejection region? My rejection is this spot. If it is a two tail test, it is this spot. Suppose it is a one tail test and I am not bothered about this side, for example, forget it, then I am only bothered about this side, right, this rejection region, right. So, I am only concerned about this much, okay. So, let us be very clear about it. So, what it is saying is it determines the direction of the hypothesis test, that is either lower tailed is this one, this part, or upper tailed, this part, the right hand and the left hand is the lower, upper hand is the right, of the sampling distribution of the relevant sample statistic being tested. It indicates the range of sample statistic values that would lead to a rejection of the null hypothesis. Now, the parameters that you are using, the values of these parameters will decide whether we would accept or reject the null hypothesis. As I have already said, you are not testing the alternate hypothesis, you are always testing the null hypothesis. So, my null hypothesis is saying ki if anything is lying within this zone, let us say this zone, okay. If it is lying within this zone, then I am not rejecting my null hypothesis, right. But something is lying here in this rejection places, let us say, right. So, let me again clear, maybe make a new diagram for your clarity, right. So, what I am doing now? So, I am saying my rejection zone is this place, okay. Suppose a two tail test, it is these two sides. If it is only one tailed, then only I am bothered about maybe one side, whichever, right or left, right. So, I am saying here. So, well, that will decide whether my, suppose my mu falls beyond this, my statistics, my calculated value, which we calculate the z value or the t value, right, say we say if the statistic calculated value comes beyond this region, then we will say it is falling away from the acceptance zone, which is this up to this much, right, and so therefore it is to be rejected. So, the null hypothesis is rejected and the alternate is then accepted in that condition. So, the what it says, for example, for the null, mu is equal to mu 0, we have already looked at this earlier also, and in the alternate we are saying mu is not equal to mu 0, right. So, it implies that the sample statistic values which are either significantly smaller than or greater than the null hypothesized population mean mu 0 will lead to the rejection of the null hypothesis, that is what I said. So, if we go back and see, if it is falling beyond this limit, this acceptance limit, right, then you are saying it is to be rejected. Hence, it is necessary to keep the rejection region at both tails of the sampling distribution, but it is not always true, because if it is only when you are clueless about the direction, you do not know which direction the thing should move. For example, suppose the mean of the class is 10 and you are trying to, the mean of the population is 10 and you are trying to see whether the mean of the class is coming less than 10 or more than 10, you have no idea. In that condition it can be even 8 or it could be even maybe 13 or 12. So, in such conditions when I am not sure of it, I will go for a two-tailed test. But suppose I am sure that the boys of the students of this section are more than the mean of the class, right, then in that case I will never test for the left tail where it is going, this part I will not check the left tail, right. I will only check for the right, whether actually it is true that the samples, the class mean the average mark or whatever it is more than the mu which is the class population's mean, right. So, this type of test is called a two-tailed. Okay. Now, let us look at this, it is I think very clear. So, this is my, up to this is my my acceptance, right, acceptance region, H0 is accepted. Now, what is this alpha? This alpha is nothing but it is called as the significance level, okay, significance level. Alpha is very important because the researcher has to decide at what level of significance does he want to test his hypothesis, okay. Does he want to test his hypothesis at 1%, 0.01%, 10%, 5%, it can vary anything, right. So, that means what, 1 minus significance or alpha is my confidence, is it clear? Okay. Now, look at this rejection zones. So, since this is a two-tailed test, so what has happened, my alpha has been split into two parts, right, because there can be rejection in both sides of the distribution. So, that is why what we have done, suppose it would have been 5%, let us say my significance or alpha is only 5%, there we would take two sides of the distribution, we will divide it by 2. So, that becomes 2.5% to the right, left, and plus 2.5% to the right. This is right side, this is left side, okay. So, this is the left hand. So, either way it can fall, okay. So, if it goes beyond this values, this side and this side, then you are rejecting, right. Now, coming to the one-tailed. So, in this case what we are saying is for as I said earlier also, there can be a right tail test and left tail test. So, if mu is less than equal to mu 0 and let us say for a null hypothesis mu is less than equal to mu 0. So, the is equal to case is always attached with the null, if you can observe it, right, and alternate is mu is greater than mu 0, that means the population mean is greater than the hypothesized mean, right. Similarly, in the other case for a left tail test, mu is greater than equal to mu 0 and the alternate is mu is less than, right. So, it implies that the value of the sample statistic is either higher or lower than the hypothesized population mean, which is the mu 0, okay. This lead to the rejection of null hypothesis for significant deviation from the specified value of the sampling distribution, okay. This is very do not get into things, this is very simple, okay, very simple. You just need to understand ki whether the value that I have counted, whether the whether my calculated value is falling within this limit of acceptance or it is falling beyond my acceptance to this side or that side, that you have to check. Thus, the entire rejection region corresponding to the level of significance alpha lies only in one tail in case of a one tail test. So, as we can go back and check. So, suppose this is two tail, maybe I have a one tail, okay. Now, this is the one tail, okay, let me finish this. So, this type of test is called a one tail, okay. Now, let us look at this case. Now, if you see this, here the rejection zone is lying here, correct, and in this case the rejection zone is lying here, okay. So, what has happened, the alpha, which is the significance level, this significance level now need not be distributed divided by 2 because it is moving to only one side. So, the entire alpha of 5% may be, suppose we take a 95% confidence level. So, 1 minus 0.95 is equal to 5%, which is my significance level. So, that is now coming to this end, okay. So, now for example, you see now here mu is greater than equal to mu 0. Mu is greater than equal to mu 0 and H1 is my alternate hypothesis, mu is less than mu 0. So, when mu is less than the mu 0 mu that means my population this population mean is I am saying less than the hypothesized mean, then it is a left tail test, and when it is more it is to the right tail test, right. I think this is clear, one tail, two tail. So, let me now go to the some examples how to develop hypothesis. See, you have understood by now the direction of the test, the tail, that which tail you are trying to check, and the significance level, which I said is nothing but 1 minus the confidence level, right. So, that is very clear. A researcher can decide, and it is the researcher who decides, nobody else tells him or her ki what to, how, what is the significance level they should be taking, right. So, now this is the example. Now, kindly read the example with me. A generic brand of a drug now markets a capsule with a 50 milligram dose. What is it saying? It markets a capsule with a 50 mg dose. The manufacturer is worried that the machine that fills the capsules, has come out of calibration. It may be worn and it has been an old machine or something, and is no longer creating capsules with the appropriate dosage. Okay. So, in such a condition, what is the research question first, let us say. Suppose this is the condition. So, you can again go back to the case and see. So, if this is the condition, what is the research question? You can think on your own what is the research question, by the time I will show you. So, kindly try to develop your own research question and the hypothesis. Okay. So, research question: does the data suggest that the population mean dosage of this brand is different than 50 mg? The question is, he is asking a question, does the data, whatever data you have collected of different samples, right, does it suggest that the population mean is different than 50 mg? Okay. So, what is the response variable you are trying to check? The dosage of active ingredient found by a chemical. So, what is the dosage? This is my response. I am interested in checking the dosage. Now, the null and the alternate. So, on the average, the dosage sold under this brand is 50 mg. So, population mean is equal to 50 mg, right. So, mu is equal to 50, right. This is my null hypothesis. I am saying that my dosage under this brand is 50 milligram. What is my alternate? Now, it is not 50 milligram, obviously. On the average, the dosage sold under this brand is not 50 milligram. So, my mu is not equal to 50 milligram, right. So, this is a one or two tailed hypothesis, as it is it is not equal to. So, it can be less than, it can be greater than. So, it is a, therefore, it is a two tailed hypothesis. Okay. Now, I would suggest kindly do this exercise with me, right. Suppose there are 2-3 examples which we will cover. Suppose we are interested in a population of 20 medium sized firms of the same size, all of which are experiencing labor turnover problems, right. The past record shows that the mean of the distribution is 120 employees. How much is the mean? Mu is equal to 120 with a standard deviation of 45. Okay. A sample, now sample is marked as n is equal to 5. A sample of this 5 firms gives this this is n is equal to 5 in this case, means the 5 firms we have taken, do not okay, and gives a mean of annual turnover of. So, mean of this, now this mean of annual turnover as 100 employees. Now, what is this mean of? Now, out of these 5 firms. So, this is the sample mean, right. So, sample mean is 100, the population mean was 120, the sample mean was 100, taking this n is equal to 5. Okay. On the basis of this information, can we claim that the sample mean is consistent with the population mean, or is it significantly different, or is it not different, right. The level of significance is 5%. Now, you need to, suppose you are a researcher and you are doing some research in HR or something, then you need to test this hypothesis. Okay. So, first of all, kindly formulate the hypothesis. So, solution, taking the null hypothesis that the mean is 120, we can write mu is equal to 120 employees. So, mu H0 is, what did it say here, the which gives a mean of 100 employees. So, now it wants to check ki whether this mu is correct or not. So, what it is trying to say, the null hypothesis is checking. So, if it is not equal to 120, then we can say there is a difference between the population and the and the sample mean. So, that is what he is trying to check. So, either mu is equal to 120 or mu is not equal to 120. So, if it is 100 or 90 or 130 is a different case. Okay. Similarly, another example, sample of sales in similar shops in two towns let us say A and B are yes, okay, are taken for a new product. Town A has a mean sales of this much, variance is this much. What is variance? We all know, sigma square, standard deviation square is equal to variance. Okay. So, size of the sample is 5, B mean sales 61, 4.8 and 7. Now, is there any evidence of difference in sales in the two towns? Is the sales of these two towns different? Use a 5% level of significance. So, if I am saying 5% level of significance, what is my confidence level? Then 95%. Okay. For testing the difference between the samples of the two places or the two samples, for significance of for testing the difference between the means of two samples, okay, sample A and sample B. Now, kindly proceed and please do the develop the hypothesis. So, taking the null hypothesis that the means of the two populations do not differ. Obviously, when you do not know whether there is a difference or not, how can you claim anything? So, you say there is no difference. So, the first condition. So, null hypothesis is that mu 1 the mean of the town A, I could have said mu A and mu B also, right, is same. Similarly, otherwise I would say mu A is not equal to mu B. Okay. So, either it could be less or it could be more. So, when I do not know, again it is a two-tailed test. Third, and I think this is the last, the mean produce of wheat of a sample of 100 fields in 200 is, actually this is 200 pounds per acre with a standard deviation of 10, right. So, what is saying? N is equal to 100, mu 1 is equal to 200, right, standard deviation is equal to 10, right, standard deviation of the first one. Similarly, N2 this is N1, N2 is equal to 150, the mu 2 is equal to 220 and the sigma 2 is equal to 12, right. Can the two samples be considered to have been taken from the same population? See, why do we do this test? That the test of hypothesis is done to, in order to, main idea is to check whether the sample is actually coming from the population that we are intending to check or not, right. So, is the sample a part of the population or not? This, to check this only we do the hypothesis testing all the time, right. So, in this case again I am taking 5% level of significance, right. So, what is the solution? The null hypothesis that the means of two populations do not differ. So, we write again mu 1 is equal to mu 2 and mu 1 is not equal to mu 2 is my alternate, right. Okay. This is a new example that I am starting. So, this example you see, this is slightly different. Now, what it is different and how it is different? Well, it says many people are starting to prefer vegetarian meals on a regular basis. Specifically, a researcher believes that females are more likely than males to eat vegetarian meals on a regular basis. What is he trying to say? Now, nowadays people are fed up with non-vegetarian meals and they are more preferring vegetarian meals, and this is more true for females, right. So, he is trying to make a study on this, because this will affect the kind of advertisements, the kind of sales a company makes for vegetarian versus non-vegetarian foods, right, or even restaurants can make that. So, does the data suggest that females are more likely than, this is a research question, right, that females are more likely than males to eat vegetarian? That means, do more number of females consume vegetarian meals in comparison to the males? It is what is the question. What is the response variable? The classification on whether or not a person eats vegetarian meals on a regular basis, whether you are eating a vegetarian or not, and what is your gender. Okay. So, gender is my explanatory variable. Okay. Now, what is the null hypothesis? There is no effect. First I am saying no, gender has no effect, there is nothing like this called that females will be more inclined towards vegetarian meal than the males, there is nothing like it. So, what is saying that there is no gender effect regarding those who eat the vegetarian meals on a regular basis, right. So, the proportion of females is equal to the proportion of males. Okay. But what is my alternate? The alternate is, see, this is interesting, females are more likely than males to eat. I am not interested to know that females, there are less females than males to eat. I am not interested to eat vegetarian meals on a regular basis. So, that is for this reason I am only interested that the proportion of females having vegetarian meals in comparison to the proportion of males is greater than the males. But that means if I do it in terms of the let us say distribution, now I will say ki I am not interested for this side, I am not interested for this side, I am only interested ki whether it is greater than or not, right. So, this is what is a condition of a one sided alternative or one sided one tailed test. Okay. Well, let me close this session here. What we discussed today is we have started developing hypothesis, and I also again I am reiterating, developing a null hypothesis is an alternate is very important, because if you do it wrong then your entire study will be a error full completely errored. So, there will be a lot of error in the study and it will be a wrong study. So, kindly understand, have patience in learning this thing and understanding how to develop the null hypothesis, what things you should keep in mind. If you do that, it is very simple, and if you make a error then it can be costly to a researcher. So, I would suggest you take caution and do the null hypothesis, development of the hypothesis. Thank you. We will meet in the next session. Thank you so much.